All right, so let us look at a couple of problems. So first, it's an integral problem. That is integral 5 minus sine of t over 2 and then square. Okay. Sine of t over 2 and dt. Okay. So we want to evaluate this integral, and apparently we would like to use the u substitution. So set u equals 5 minus sine of t over 2, right? And then du gonna be negative 1 over 2 cosine of t over 2 and then dt. Okay, because of the channel. And then after that we can substitute. So what we have here is it's going to be u squared, right? So cosine t over 2 dt is going to become into negative 2 du. So it's negative 2 du. So it turns out we're going to have it's negative 2. I take those negative to the outside of the integral u squared du. So the value of this is going to give us negative 2 times u cubed over 3, right? Plus constant c. And replace this u back with 5 minus sine t over 2. So that gives us this negative 2 over 3. 5 minus sine of t over 2 cubed plus constant c, and then we're down. Okay. That's it for the first example here. Now we can look at another one. So move on. The second one is so integral x cosine of 9 x squared dx. Okay. And currently for this one, we can also use a simple chain u substitution. So set u is equal to 9x squared. So du equals 18x dx. And then we're starting to do the substitution. So they're going to give us, this part is going to become into cosine u, right? And the x dx, since du equals 18x dx, so it going to becomes into du over 18. Okay. So turns out this is going to be 1 over 18 integral cosine u du, and we know that the antiderivative of cosine u, which is sine of u, right? And then plus c. Of course, substitute this u back with 9x squared. That gives us is 1 over 18 sine of 9x squared plus constant c. Okay, so that's the second example. Also very very straightforward. Okay, so now let's look at another one. Third one. So the problem is let's see, so it's a 32s cube over square root of 10 minus s to the power 4, and then ds. Okay, and then ds. So this is another problem that you can take a look. So what we can do here is you can think about it as since this on the bottom it's a square root, so we can still do a u substitution. So set u equals 10 minus s to the power 4. Okay, and then du is going to be negative 4s cubed ds. Okay, And as you can see that we got x cubed ds here. So for us, it should be good to do the substitution. So we can do, since we have 32 s cubed ds, so right now, as you can see, that negative 8 du gonna becomes into 32 s cubed ds. Okay. So we can substitute that. So give us negative 8 du, and then over square root of u. Okay, over square root of u. So up to here, things become pretty straightforward. So this is going to become into negative 8 integral 1 over square root of u du. And the antiderivative of 1 over square root of u, it is actually, it's 2 times square root of u, okay? And then plus a constant c. So it turns out this is going to give us a negative 16 square root of u plus constant c. And of course, we can substitute this u back, which give us is negative 16 square root of 10 minus s to the power 4, and then plus constant c, and then we're done. Okay, so those are 3 problems using the u substitution. So hope you enjoy this video. Thanks.